In this weekly report, we completed our Simulink block diagram, and let me show you what we did extra from the previous week. As we can remember, our Y positioning is not correct, and we transform our body axis velocities and our angles to the earth axis. We did this job with this subsystem. We convert our UVW and phi theta PC roll, pitch and yaw angles to the velocity north, velocity east, and velocity down. By the other words, the change in the altitude velocity. And in this subsystem block diagram, we convert this velocity north, east, and down altitude to the geodetic positions, latitude, longitude, and altitude. We are using VGS 84 datum. We explained this in the weekly report. This is our semi-major axis, first eccentricity, and we calculate M and M, and we supply this M and M to this max and calculate our latitude dots, longitude dots, and we obtain a hash dot from the this block conversion, and we integrate all of this to obtain latitude, longitude, and altitude, and the output of this subsystem gives us geodetic position, and we convert from radians to degree, and we add our initial altitude 500 meters. Actually, our state space are designed for 15,000 feet, but for better visualizing, we are simulating our plane in at 500 meters, and we supply our longitude, latitude, altitude, roll, pitch, and yaw values to the FlightGear simulation block, and we also add saturation limits for attitude angles plus and minus 10 degree. And now I want to show you our simulation. This is our aircraft, and now it is cruising very well. Last week, when we changed the aileron or rudder angle, after a while, our aircraft going very strange, going from Y direction, no position, no velocity at the X direction. But now, after this axis transformation, we correct this defect, and now, as you can see, it is going very well. Let me start the simulation again to visualize the rudder inputs better. As we change the rudder inputs, it's again the same thing. After a while, I will change the rudder to the 0, and we will see our aircraft is going really very well. There is no problem in the elevator also. That's it. This is our block diagram. These are our inputs for elevator, airline, and rudder inputs. Currently, we are using LQR controller, and we calculate these gains, LQR gains by using this LQR functions for longitudinal and lateral motion. We calculate two separate LQR gain, and that's all. We finish this project in this week. Our studies will continue until we successfully implement the Kalman filter for linear quadratic Gaussian controller. And that's all. And thank you for listening.